Embodiment theories increasingly inform musical research. This diagram illustrates the concept underlying embodied cognition, where information about our actions in the world reaches the brain through our sensory organs, thus providing the basis for embodied experience. Schiavio highlights the primary role of experience in embodiment theories. These theories align with traditional but intuitive approaches to musical education. He suggests that we need to examine the nature of first-person experience in more detail, because phenomenological approaches may lead to novel insights and new ways to study musical experiences and music education. Forms of embodiment in music, based on large, very visible body movements, and which reflect rhythmic elements and overall emotional tone, have received much attention in recent years. Korsakova-Crane distinguishes this superficial level from the primary deep level connected by tonal relationships, important for coding meaning in music. She suggests we investigate this deeper level through basic musicology and cognitive neuropsychiatric studies. An intimate link between mechanisms underlying sound perception and production is long recognized, but the precise nature of this link is unknown. Increasingly, neuroimaging studies point to brain regions shared in sound's perception, production, and imagination. We suggest the hypothesis that, in addition to central substrates, mechanisms underlying auditory vocal processing also share peripheral substrates. In classical musicology, ideas about the participation of bodily sensations in musical understanding, particularly vocal motor sensations, have been repeatedly expressed. For example, Asafiev's vocal gravity of musical intonation, Bingham's observations that each tone demands a specific act of adjustment, Proll noting that while we hear with our ears, there is no doubt that our vocal organs themselves play a greater part in discriminating them as higher and lower, and Sabaneev's reports of involuntary movements in the region of the mouth and larynx, which always accompanied tonal reception. Recently, and stimulated by first-person observations described here, an MRI study investigated the nature of changes that occur when changing vocal pitch. Switching from low to high note humming was accompanied by widespread coordinated changes in the absence of articulatory or postural input. Note the posterior displacement of the cervical spine when humming a high note. These changes support the view that a peripheral substrate exists that could be recruited during sound perception, production, and imagination. The specific nature of the role of bodily reactions in sound processing is still poorly understood. These little noticed, subtle, and seemingly hidden bodily reactions are difficult to investigate using established neuroimaging methods. We drew inspiration from the phenomenological research method developed by Husserl and the work of Philip E. Vernon. As a first step, it is essential to characterize, as far as possible, these bodily reactions, their variability of manifestation, and their exact localization in the body. This study has two parts. Our overall aim is to investigate the nature of bodily reactions and subtle motor sensations that occur during the imagination and perception of musical sounds and phrases within the context of the theory of embodied cognition. In the first part of the study, presented here, we investigate bodily responses to the internal hearing or audiation of single low and high-pitched sounds. We recruited 21 professional music students. The students, naive to the goal of the experiments, were asked to internally represent low and high sounds while adopting neutral, flexed and extended head positions. Immediately on completion of each task, students recorded their observations. This diagram illustrates the range of recorded observations. Most participants noted sensations involving the vocal apparatus. In addition, participants noted physiological changes, such as those affecting pulse and respiration, sensations within specific regions such as the face, ears, neck, shoulders, back, diaphragm, stomach, and legs, and more general sensations of tension, relaxation, or discomfort. Observations in the final group relate to the ease or difficulty of imagining sounds in different head positions. Here are examples of observations recorded by an individual and from the group as a whole. Participants recorded a wide range of observations, from muscular sensations involving the vocal apparatus and other regions to those related to feelings and physiological changes. Clear differences between tasks were often recorded for each posture. Particularly interesting were observations relating to the ease or difficulty of imagining sounds depending on posture. Imagining a low sound was usually easier with the head flexed, and imagining a high sound usually easier with the head extended. These observations suggest that the ability to imagine sounds may be constrained or enhanced depending on posture. Although the number of participants is small, our results align with historical accounts and ideas such as those referred to earlier. We suggest our results support the idea that peripheral substrates may play a greater part in processes underlying musical cognition than traditionally thought. Further, and illustrated by this diagram, we suggest that in addition to sensory organs and action in the environment, we need to consider the role played by sensory systems and action in perception. Until now, bodily manifestations associated with sound processing have been largely neglected. Their presence requires explanation. It is time to revisit historical ideas and theories in the light of modern embodiment theories and technological advances. If confirmed, the presence of shared peripheral substrates for musical perception, imagination, and vocal production has far-reaching implications for musical education and for enriching our understanding of the body's role in musical cognition.